Namaste. I am back here with the next set of lectures on Geographic Information System. So, specifically in this particular module, in this week, we would look at what is the data, what kind of data can be handled by GIS, what are different data models. I have been speaking about data models all through the last 2 weeks, but today we will understand, or maybe in the set of these lectures, 4-5 lectures, we will understand what are different data models with examples. We will also look at what are different data types that a GIS can handle. So, these are very two important aspects if you have to work with GIS. The first 2 weeks was to understand what GIS really means, but now onwards we will start handling data. Okay. So, in today's lectures, we will be looking at how do we represent a real world. We will also look at what are different data. For example, looking at discrete data is one set of data, other one is a continuous data. So, we will look at both of these, then we would look at specific aspects called as objects and fields. These are extremely important in terms when you are looking at the data and how you actually represent an object and a field. So, how the representation matters, because that is what is actually being converted as a data model. And finally, a data model. In the next set of slides, we will look at what are different data models and the examples with that. So, now when in the previous week we did understand what do you mean by a representation of a real world. So, when we look at real world is actually a infinitely extremely complex. Okay. It has both natural resources, it has all changes made by man made, and and various features that has been completely changed as by the man. But how do we represent it? So, we can represent it, each of the aspects in the data model, as entities. So, now when we are looking at this, once we convert it to a data model, it should when you have a spatial database, it, as I said, it only represents a limited view of reality, because everything is in the form of entity and relationships to the database. So, when we look at a spatial database, it is a model of reality known as data model. So, whenever you are looking at a data model, you are actually spelling out that this is a model of the reality and is representing the real phenomena. The user sees the real world through a medium of a database. So, now database is a heart and muscle of your entire system. Without database, your data model does not exist, neither your real world. So, if the real world has to be transformed into a data model, then you need to have a database, otherwise you cannot retrieve any information or do any quantitative qualitative aspects in terms of having information. So, real world features can be represented using both discrete and continuous data. So, whenever we consider data, there are two types of data. One is discrete data, discrete points, and another one is a continuous data. So, on your right hand side, I have a set of layers. See, this is a real world. Okay, whatever we have here is a real world. So, now then I have a land usage. Okay, it is in the form of squares or pixels, or in terms like last week I spoke about raster. Okay, set of number of collected pixels in M cross N matrix is nothing but your raster image. Okay. So, each of these pixels will have its own specific values based on different intensities of or different values. I will come back to this, how it is represented, how it is captured, etc. Then you have an elevation layer, which again a raster. You have a parcel layer, which is both a collection of a raster and a vector. Okay, you have a lines, you have a set of values. Parcels can be only vector, parcels can only be raster, parcel can be both vector and raster. So, you have this here representing mainly some part of it is raster, whereas this is a vector. You have this as a vector layer and you have this customers as again a vector layer. So, when we look at this each of these points here that is represented in the customer layer or a street that is represented here is not a continuous data, it is a point data, number of points make a line segment. So, when we look at this, it is represented as a discrete data, okay, whereas this phenomena wherever you see you have elevation data, it is a continuous phenomena, it is not a discrete phenomena, but a continuous phenomena. So, when I say discrete data, it is clearly defined by entities and easy to locate. So, it is extremely easy to locate and it is defined by entities. Every entity, if every entity has its own value, then it is a discrete data. Okay. It is known as a definable boundaries. For example, here if we look at the lake has a boundary, okay, it has a specific area, it has a maybe a lake has different characteristics. So, all of these are discrete datas, okay. Edge of a lake clearly is identified with respect to the other land uses, that is forms it as a discrete quantity, okay. Now, if let us say I have this layer, then I have an elevation layer or any other layer which is a continuous layer that is put on it. So, both of these layers represent different quantities, but when you look at this lake, it is a discrete data, but when you look at elevation which is overlaid on it, then it is an completely and continuous data. So, that is a continuous data, it is a discrete data. So, GIS has that efficiency or capability to handle both discrete and continuous data together. And when you look at continuous data, I have given I just spoke about the elevation part of it. If this is elevation map, so you can look at the elevation as a grids, continuous grids here. So, this is nothing but your continuous data. When I represent a phenomena where each location is a surface of on a surface is a measure of maybe a concentration level, maybe relationships, okay, maybe relationships from a fixed point or from an emitting source. So, it can be any kind of thing. If you are looking at remote sensing data, it can be a relationship between the emitting source, because the amount of light that is reflected back and you remove all other interferences, and that the light that actually reaches the sensor back is the amount of energy that is recorded as a value in a pixel. So, that is what is the relationship with the emitting source. So, amount of, for example, if you have a satellite here and you have a this, let us say my left hand here is a satellite and my right hand here is your sun, okay. Now, you have a solar energy, it hits the surface, and now as it is being captured here, before it hits the surface there is atmosphere which actually has certain ways of absorbing certain amount of energy here. So, some part of the energy is lost. When it hits the surface, there is some part of them is reflected back. Again, you have some part of the energy that is removed in the atmosphere, and finally, when it reaches the sensor, you have very less energy that reaches the sensor. So, the reflected energy when it reaches the sensor, it is the amount of energy that is recorded. So, based on the kind of reflection, the amount of reflection you have the DN values that is actually registered on this particular platform. Okay. So, now when you are actually looking at this, it is also saying that you are actually collecting every point on the earth's surface as a source of a pixel. So, based on the size that your sensor is able to look at the ground, you will be able to collect so much of information. If I say my sensor is 30 meter by can sense so much of area, when I say 30 meter resolution, it means that details of 30 meter by 30 meter is captured by that sensor. Okay. So, when you look at this continuous data, these are also called as field, non-discrete or surface data. There are different types of surface data which I will also speak to you probably in the next lecture. So, when continuous representation is normally complex. So, you have to look for example, when you look at elevation map, temperature maps, etc., these are quite complex in terms of representation and interpretation also. Most of these raster data may fall in the continuous data category, and most of it all of it basically falls under the continuous data categories, and it is different. It is not so easy to differentiate each categories in a very smooth way as we do in a discrete data. So, variation needs to be approximated using discrete representation certain times. So, what you do is you convert the continuous data into a discrete data in order to show the variations. That is extremely important when you are actually handling a continuous data. Okay. So, when we are trying to represent a real word, as I said, real word is first of all a complex word to represent, and moreover it is dynamic. So, to capture this dynamic complex real word, you need to have a data model which can handle every kind of data. So, when we are looking at the boundaries that can be represented or modeled as discrete or continuous values, we have to look at what kind and how it has to be captured. So, the first thing that you do is you look at the distinction between what is a discrete and what is a continuous values that are there on the on your data set or in your study area. For example, in this image, when I am seeing this particular image, this is a discrete image. Okay. So, you can easily find out, you can make this particular raster data discrete easily, because you can understand what is the variations in this particular raster data, whereas when you look at the continuous data, it is difficult to find out the variations. This is another example of a discrete data. If you look at this, is again a discrete data. So, most of the features in a continuous or a discrete data have the values, certain values associated with it, and when you look at the real word, it is, you do not have anything that is separately discrete or separately continuous. So, you should look at something that is in between a discrete and a continuous. So, when you are looking at the real word, you will not be given anything that is completely discrete or completely continuous. So, your data or the database should be able to handle, or a data model should be able to handle both discrete data and a continuous data in an effective way. And when you are looking at the spatial data, storing of a spatial data in your computer is especially in the form of a discrete, is much easier. But when there are your continuous data, your computer has certain limitations, right, which we will also see how it is quite limited. So, handling and storing, computers have a lot of limitations in looking at continuous data. And when we look at data type, so when you have a numeric description, if it is a discrete, these are independent numbers, and when you look at continuous, it is a range of values. Okay. So, when you have a geographic distribution, it is abrupt boundaries, and when you look at continuous values, it is a spatial gradient, you have a gradient of values. Okay. Now, when you look at this discrete or continuous data, the first thing that we have to look at is objects. Objects are extremely important, it is equivalent to your entity relationships. Okay. But when you look at an object based relationship or object based ontology, it describes the world of as a space that is filled with discrete identifiable units. For example, here, if you look at this image, this is a discrete data, these are three different discrete data. So, these are identifiable units that are present there. These objects, each of these objects has a spatial reference, usually in the form of geographic coordinates. Geographic objects, now we have objects. So, there are three different objects in that image, but in case you add geographic value to it, it becomes a geographic coordinate, and this geographic objects populate the entire study area. And most importantly is that when you look at geographic coordinates, these are quite distinguishable. So, you can distinguish each and every object. For example, here in this image you can distinguish this is a house, this is a single storied house, whereas this you can see is as industry that is next to the house, right. So, when you look at it, these two are discrete quantities, okay, and are distinguishable, discrete, and have a bounded entities. So, when you look at this, it is a bounded value. Now, the space between them is potentially empty, that is what we mean by discrete. Continuous has continuous values, if it if there is a house, it stops, then you have another house, it stops, then you have an industry. So, that is a continuous value, whereas discrete you have a space in between them. So, for example, we have houses, factories, roads, rivers, lakes or pollution plumes. So, continuous, if it is there, then it becomes a continuous data, you cannot distinguish the boundaries. But if it is discrete, you have a bounded value, you have a space, then you have another maybe another object, then it becomes quite discrete. Okay. So, when we are looking at this, object is a digital representation of an entity. You can call object as an entity, but in a digital representation it becomes an object, but in a real representation it becomes an entity. Okay. When you look at the object, it can be defined in 3 different ways. You have point, line, point objects, line objects and an area objects. So, object view, when you say that it is an object view, is an empty space littered with objects. So, if you consider this, if you have this entire slide, if you do not have anything written here, it is an object in a database. Okay. So, now I put in some data on it, some object on it, it may be a point object, it may be a line object. Line object is representing this road, point object is representing this location here as an maybe an industry. Okay. So, each of the entire board is nothing but an empty space. Okay. But it is a collection of point objects, line objects and area objects. It may be a collection of all of these, but even one of these. So, that depends on what kind of object it is. Now, objects, for example, if we consider it as roads, are characterized by maybe location, where does it begin and where does it end, because road is characterized by a line segment. Line segment is made up of 2 points. So, you need to have a starting point, you need to have an ending point. Then shape, how many lanes does it have? It is a 2-lane road, 3-lane road, 4-lane road or a 6-lane road. So, depending on how many lanes that it has. Then size, how far one can travel on it. So, number of line segments that connect, how far it travels. Then you have orientation, in which direction one can travel. So, that direction is extremely important in case you are trying to find out what is the route structure in the entire database. If you are trying to give the distance, you are trying to give a route. So, you need to give the orientation, otherwise you will not be able to tell the user that this is the route that you will take to go into this place. Okay. So, similarly we have fields. A field, when I say a field, field based ontology or field based representation describes the world as a collection of spatial distributions of phenomena, or it is a continuous data. For example, on the right hand side, the elevation details that I have represented is a continuous data. So, when you say it is a geographic field, it is a geographic phenomena, that is, for every point in a steady area a value can be determined, or geographically there is a value associated as far as the earth reference is concerned for that particular phenomena. Then geo field represent a continuous graphical variable over some regions of the earth, or if it can have many, when you look at, it is not only just one value, it can be many value also. So, but it represents a continuous geographical variable. Please understand this, it is a geographical variable. So, it has a geographical quantity associated with it, but these quantities are variable based on earth's reference. Okay. You have to always look at the earth's reference when you are actually representing any GIS data. So, what is the earth's value, what is how it is represented as a data model. So, looking at that, it is a geographical quantity also, which means it has certain ways of represent. It can tell you where you are exactly, but it will also tell you what you are. Okay. What is the value, what is this region that is dependent on it. So, all these values are given as a field in a continuous data. When you look at a field view, its a value is defined for every location. Natural features are more often fields when you are representing. The very good example is whatever I have represented here is a digital elevation model, which is actually representative of a field, or your entire land use data can be represented as a field. Land use data can also be represented as again it can be even represented as an object in case it is converted as a line, point or a polygon. So, if it is all land use features are converted as polygons, then it becomes a polyline object or a polygon object, sorry. So, that is how we use objects and fields. Now, when you look at fields, every place has a value. Please remember this is extremely important. Every place has a value. Fields can be represented as a raster data. For example, DEM and other terrain models, we will look at this. It can also be represented as a vector data in a form of TIN, that is triangulated irregular network. Okay. Object versus, when you look at objects versus field view, if it is the first one is as distinct as possible, whereas the field is not quite distinct, it is a continuous value. If it is a categorical value or an integer variable, then places with the same value can be grouped in an object. For example, if there are number of polygons with the same value, it can be easily grouped. Okay. Whereas now if the entire elevation data is same, it is not possible to group it because it is a continuous phenomena. So, that is why the object can be easily grouped, whereas the field cannot be grouped much easily. And when you look at a representation of an object and a field, if it is a discrete value and it is called as an object, then it is point, lines and a polygon, okay, which can be represented as simple as this: number of points, okay, 2 points form a line, okay, number of lines, number of line segments that are connected together forms with a closing value forms a polygon. Okay. When it is a continuous representation or you are speaking about fields, then it is number of squares that are together in a form of a matrix. Okay. It has m number of rows and n number of columns, then it is represented as a continuous fields or a continuous value. Okay. So, now we have been speaking about data model. So, now what do you really mean by a data model? Data model defines the rules to convert real geographic variations into discrete or continuous representations, which means that you are converting the real world into either a discrete value or a continuous value, without which a data model does not exist. In a data model, a real world is simplified into 3 spatial entities. It is point, line and polygons. Okay. When I say polygons, some people can even put it in the words such as area or surfaces. It can be areas, surfaces and polygons. So, point, line and polygons are the things that this data model signifies. Now, based on these elements, GIS data model can be classified as vector data model and the raster data model. So, in a vector data model, as I said, is a collection of point, line and a polygon. Raster is nothing but a gridded cells, which is actually representing different quantities based on it, maybe its reflections, based on its various representations or thematic features. So, to represent all the natural and man-made features on the earth. So, just to signify that, what do you mean by a data model? It is nothing but rules, in inverted quotes, rules to convert a real geographic variation. So, please keep this in mind, it is a real geographic variations. Okay. Each of these real quantities are converted as discrete or continuous representations. So, you are converting a real value to discrete or a continuous representations. So, this is nothing but what is called as a data model. So, when we come back to in the probably in the next session, we look at different types of data model. For example, as I said, it is a vector data and a raster data model. We will also look at what are different vector datas that are vector data model that is there. Okay. There are different ways of representation of a vector data. So, we will look at those types of model. There is also raster data models, different ways of representation of a raster data model. We look at least one of them, how does that particular data model represents the entire data space. So, with this summarizing today's class, we revised how do we represent a real word. Real word is extremely dynamic and is complex. So, this has to be represented in a form of a data model. So, normally when we are creating a data model, everything is in a form of an entity, and because of which it may mimic a real word, but essentially not the entire photoscope of the real word. Okay. So, when you look at a discrete data, when you look at the real world, it can be divided into discrete data and a continuous data. You can extract it. So, when I say discrete data, it has a defined boundary, whereas continuous data is a complex relationship of complex representation of a relationship with respect to a fixed point. Okay. So, when we are looking at objects and fields, objects are discrete representation of entity using a point, line and a polygon, whereas when I say fields, it is a collection of spatial distribution varying continuously. So, you have a huge amount of spatial distribution values. So, these values are connected to a geographic coordinates, and these vary across space, and you have, and it has been captured by various measures into the data set. So, that is what is called as a fields. We looked at how do we represent objects and fields. So, objects as point, line and a polygon. Fields, the same point is same point, line and polygon is there in a field. Representation is represented as number of pixels. Okay. If it is a point, it may be a single or many pixels around it, whereas a line is a collection of pixels, okay, in a particular way, and if it is a polygon, it is a huge area, or it is an area and a collection of pixels. Okay. So, we also looked at data models. So, what do you mean by a data model? These are rules that are representing the real world, which convert the real world phenomena into an into a database, and helps us in querying. In the next session, we shall discuss about the vector data model first, and different types of vector data model that can be represented. So, till then, thank you very much. Have a nice day.